Oh, sorry. Okay, hello y'all. Sorry, I'm making all these separate so I can take a little water break or whatever in between. Okay. So we're doing number, if you would focus, please. There we go. All right, we're doing number 4 now, which is number 2. All right. Okay, so this one is a little weird, okay? So F gives you, so you're looking for which one of them converges, right? So we have the first one, n equals to 1 of infinity, sigma notation, of 3 of n over n plus 2, right? And so when I was first doing this, I was like, okay, well, I'm just going to do the nth term for divergence, right? And that's where I take the limit as n approaches infinity of 3 of n over n plus 2, right? And if I do that, I'm going to get infinity over infinity, right? Which, I mean, L'Hopital, right? And I would take the derivative, and that would just give me 3 over 1, right? So the limit as n approaches infinity of 3 over 1, which is not 0. And the nth term of divergence series test or whatever says if the limit as n approaches infinity of a of n, our thing right here, our series, does not equal to 0, then the series diverges. And that's nice. I mean, f is off. Really simple, not too bad. All right. Now, you would do the limit, I mean the nth term for divergence for all of the rest of them, but looking at, because G, H, and J are all pretty similar, right? They have 3n over n squared plus 2, right? This is G. And then H is 3n over n squared plus 2n. And then J is 3n squared over n cubed plus 2n, right? And if we remember a different a different test, and that's the limit comparison test. What you do to start off that test is you go, okay, well, I have a degree of 1 right here, right? So let's do G over here, right? I have a degree of 1 on top, and I have a degree of 2 on the bottom of 2, right? And that about equals 1 over n, right? And so whenever you're going to evaluate this, because what you end up having to do is like, well, instead of evaluating this, I evaluate this, right? And then if you look at H, same situation, right? Degree of 1, degree of 2. And here it's a little tricky, but it's going to end up being the same thing because it's degree of 2 over degree of 3, which simplifies to 1 over n, okay? And then on here, I mean, if you really wanted to go all out, you would go and you would do, all right, well, I put 3n over n squared plus 2 over 1 over n, and you do the whole mess, whatever if you find if it's a positive finite number, right? And I'm telling you now, they all do, so I'm saving you all the work, okay? But what's really important about this test is this part right here, where it goes down to this, because at the end of the day, you evaluate from n equals 1 to infinity of 1 over n, okay? And this is pretty simple, right? You can do P series test, right? Where P, or the power, is equal to 1, right? And if P equals 1, it's a harmonic series. It's a harmonic series. And that means it diverges, right? So just from like noticing stuff like this, you can cross off G, H, and J. And because we already crossed off F up here, we already crossed off F, without even having to do the extra work, we know that K is our answer. But I'm gonna go ahead and do K. You can just end the video here. I'm gonna separate them into parts. So I mean whatever. Okay. So let's do K. Segment notation, infinity of n equals to 1, whatever. 3n squared over n to the 4th plus 2n. Okay? So I'm going to do the same thing. Degree 2 over degree 4, which gives me 1 over n squared. Okay? And I'll make this b of n. And now I have to evaluate the limit as n approaches infinity of a of n over b of n, which goes to 3n squared over n fourth plus 2n times 1 over n squared, divided by 1 over n squared, which basically just means 3n to the 4th, because I just multiply by the reciprocal, so I multiply by n squared, over n to the 4th plus 2n, right? And if I'm taking the limit, don't forget about the limit, I'm going to get infinity over infinity, so I'm going to do L'Hopital. So 12n cubed over 4n cubed plus 2. Limit again, L'Hopital. So 36n squared over 12n squared. Limit, L'Hopital again. So I'm going to get 72n over 24n. Limit, L'Hopital again. And I'll get 72 over 24, which is a finite and positive number. Therefore, this applies, right? And so I will now evaluate as n approaches segment notation from n to infinity of 1 over n squared, right? And if I do p series, where p equals 2, because p is greater than 1, if we look at the p series rules thing, if p is greater than 1, then the series converges. And then if you would do, if this was for your response, you would write, because of the limit comparison test, blah, 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 you would get the full credit, right? At the end of the day, you need to know that K is the answer because of this simple trick, right? Just kind of noticing stuff like this.